Now I want to go over with you guys on your little packet that you had. This is kind of a review for your test on multiplication. So let's start with the first page with Molly. Molly has 3 packs of pencils. Each pack holds 8 pencils. There's a clue word. Every time you see the word each in a word problem, circle or highlight it. Do something so that word stands out. Molly writes 3 times 8 to represent the problem situation. What does 3 times 8 show? So the 3, of course, are going to be our packs or our groups. So our 3 is going to be our 3 groups. And then the 8 is what's going inside. Those are our pencils. So 3 groups of 8 pencils. That's what this problem would show us. Now you could draw that and put 8 pencils. In each group to figure out that 3 times 8 would give us 24. And if you counted all my pencils, you would see that there are 24. Okay, same thing on this one. When it asks for an expression, that's just a fancy word for an equation. So if we have 5 kittens, there's that clue word again, each. Each kitten has 4 legs, so you would have 5 times 4 because you have 5 groups of 4. So 5 times 4, and we should be able to count by 5s to get that answer. Down here, when it asks you to write a problem story that matches, make sure that you're doing a story that has equal groups, like I baked 7 cookies. Each cookie has 3 chocolate chips. How many chocolate chips are there in all? Or I have 7 puppies. Each puppy has 3 spots or 3 toys. How many toys do they have in all? Something like that, where you have equal groups of something. And it's always good to use that word each. All right, let's go to the next page, which is CC3. Just going to kind of go over a little bit on each page or each section. So here you are given your total first. Sally is putting 32 muffins on 8 plates. Now 32 is our big number. You're also going to see each again. Each plate has the same amount of muffins. What expression? There's that word again. That's just a math word, equation. Shows how many muffins are on each plate. When you see each in the question mark, each in the question mark is going to let you know it's a division problem. Now you're not going to see any division on your test today, but you do need to understand the difference between a multiplication word problem and a division word problem. On a division word problem, your clue word is going to be in the question mark. Also in a division problem, they're going to give you the biggest number. 32 is our total. I like to write total on top of that. So this problem, or our expression, would be 32 divided by 8, because we're putting equal groups, 8 equal groups, and we want to distribute that at 32 on them. And if we make a list of our 8s, hopefully you would have found that 32 divided by 8 equals 4. We would put 4 muffins on each plate, because 4 times 8, of course, is 32. Alright, same thing on the next one. You're going to notice that you are given your biggest number, which means it's a division problem. Let's go ahead and look on CC5. Just kind of going through each page. Hannah has 3 bags of marbles. There's that word each again. In each bag are 6 marbles. So we have equal groups. Our picture, you can be as fancy as you want, but we've got 3 bags. And we're going to put 6 marbles. We do not know the total. They do not give us the biggest number, so it is multiplication. How many marbles? I can count all of those, or I can just do 3 times 6, which hopefully we all know is 18. Okay? Now, number 2 is going to ask you to do an array. That's fine, but pay attention. They tell you your total. They do not tell you how many columns there are. So when you draw, let's do this one real quick. When you draw your array, it wants to have 4 rows. Rows go down. So the first thing I'm going to do is draw those 4 rows. That gives me 4. I'm going to keep doing these 4 rows until I get to 16. There's 8, 12, 16, and then I stopped. Some folks yesterday were trying to put 16 in every row. That is not what that says. It says you only have 16 stamps. That 16 is your total. Once you have 16, you stop. You can't put any more circles because you only have 16 stamps. How many stamps are in each row? Well, if I look in a row, 1, 2, 3, 4, there are 4 stamps or 4 columns in each row. 4 times 4 is 16, so that makes sense. Down at the bottom, there are some silly choices here. Y'all, D should automatically be marked out when you see it, that the largest number is not at the front of a division problem. You can't do it. So D, that's a silly choice. We should never look at a problem like that and think it's correct. So always look for those common sense ones, those ones that don't make sense. You can't take 5 and divide it and get a bigger answer. When you divide, you get something smaller. Now the other one that doesn't make sense is A. A. 25 is the largest number. Why would you put it in the multiplication problem? So that's the other one that is a silly choice. So we're left with B and C, A and C, and both of those will work. 25 divided by 5 gives us 5, and 5 times 5 gives us 25. Both of these will make sense when you read this problem up here. All right, let's go to CC7. Maddie, she's got 6 baskets. I think you kind of understand now that these are going to be our groups. She wants to put the same number in each basket. We don't know what goes in the group. There's our clue each. Notice that we have 42 cans. That's our total, of course. We can't go over that. How many cans can she put in each basket? Again, each in the question mark tells us this is division. So we're saying 42 divided by 6. I'll leave that one for you to answer. Down here, you're just filling in the missing numbers. Sometimes you're going to have to kind of do the opposite like division here. You're going to ask yourself, what can I multiply by 3 to get 21? You're counting by 3's there. Hopefully you remember 7 3's is 21. On some of them, you're just multiplying. Count by 2's. 2 times 4 is 8. So I don't think you'll have trouble with that. Down at the bottom, anytime you see a box, it tells you to make that a 4. So what I would do is go down through all these boxes and put that number 4. If the problem works, you circle yes. If the problem does not work, you circle no. So if they tell you what number to use, you have to use that number. CC9. These are your properties. I would really go over this page really well today. CC9, I'm going to start. This is probably one of the most important pages. So this top section is showing you the distributive property. I'm going to work all of these with you. When you see this, you are going to need to give the 8 to everybody inside that parentheses. We talked about yesterday if I walked in the classroom with a bag of suckers and I said I was going to distribute them, what did that mean? Well, that means I would go around and give everybody in the classroom the same amount of suckers. So we've got to say 8 times 6, and we're going to have to do that twice because we have 2 6's inside our parentheses. So it's 8 times 6 plus 8 times 6. Then I'm going to work those out. 8 times 6, the cake is 48 plus 48. And then we need to add the 2 parentheses together. 48 plus 48 is 96. Okay, I'll worry about the yes and no at the end. Right now, I'm just going to work my problems. Again, we've got to distribute the 6 to both numbers. So we again have 6 times 8, and then 6 times 6. We already know 6 times 8 is 48. 6 times 6, the 36 is 36. Add those up. What is that? 80? No. Yeah, 80 what? 84? I think that's 84. Is that right? 8, 9, 10, 11, 12, 13, 14. Regroup.
Yeah, 84.
Alright, let's go to C. So I already know either both of these are wrong or one's a yes and one's a right. It stopped, didn't it? No, it's still going. We're good. Alright, so here we go on this one. This one they've already distributed on C for you, so all you have to do is work your multiplication. 4 times 2 is 8, plus 6 times 2 is 12, add 8 plus 12, which equals 20. On this one, oh boy, this is a double distributed property problem. So this is what this was going to look like. You've got to give the 6 to both of these 4. So 6 times 4 plus 6 times 4. Then you're going to repeat that because they've got this down twice. Plus 6 times 4 plus 6 times 4. So you're going to have 4 6 times 4s. 6 times 4 is 24. So now we've got 24 plus 24 plus 24 plus 24 because there were 4 of those. When you add all these up, that should equal 96 if I'm not wrong. So now we can go back. We got a 96 for the first answer and the last answer. Up here, we're supposed to be finding the one that matches 8 and 12. And 8 times 12 is 96. So that means A is a yes and D is a yes. They match. And B and C are both no's. I would encourage you to really do this page, CC9 and CC10, over your properties. You're also going to see that associative property where you have to decide which factors to multiply first. I like to do the smallest factors first, but it really doesn't matter. That's up to you. On CC11, you see my page is messed up, but I think you can do this. It's basic division facts, multiplication facts. Also on CC13, these are just practice on multiplication and division. That's a good practice page, especially to practice your equal groups and arrays. Any method that you choose to find those answers is fine. Let's go to CC15. You're going to see your 2-step word problems. I don't think there'll be any of this on your multiplication test, but this is good practice on finding those clue words. Jeremy bought 9 water bottles with a $20 bill each. There's that clue word. Water bottle costs $2. How much change? That's a clue word. We haven't seen that clue word in a long time, but change is definitely a clue word for us. Write an equation. We'll get to the equation later. Let's go down here and solve it. If I go into a store, when I go up to that cashier, the first thing you're going to do is ring up my cost. So if you notice, the $20 here is not part of my cost. That's what he has in his pocket. We talked about yesterday, when you go in a store, you're never going to leave with more money than what you brought in if you purchase something. So that $20 is our total, and we'll get to it last. Right now, we need to figure out how much our bottles cost. So there are 9 bottles at $2 each. Each is that clue word, tells us to multiply. So the cost of our bottles is going to be $18. 9 times 2 is 18. He's going to hand that cashier a $20 bill. To get change, you always subtract. So then we're going to say our $20, take away that $18. He should get back $2 in change. So our equation, we did multiplication first. We did 9 times the $2. We subtracted 20, but remember 20 is our total, so that 20 has to go in front of our problem because it's the biggest number, and that's how we got our change. So they want us to use the letter C. That just stands for that missing number, so I'm just going to put that C there after the equal sign. All right, so that's your word problem page. You might do another one on that just for practice. The last page is on patterns. We see patterns in math all the time. This one has nothing to do with multiplication. You're just trying to figure out what's happening to those numbers. Hopefully when you look at them, you're going to realize they are increasing. It is not by multiplication. I will tell you they're adding something. See if you can't figure out what they're adding to those numbers. Down at the bottom, this is a multiplication table. They're just wanting you to look for patterns in here. It asks you to look for the row 6. Here's the row 6. In row 6, you're looking to see what's happening to those numbers and why 6 times a number is always even. Well, the reason 6 is always even is because 6 is an even factor. Even factors always give you even numbers. All right, on 3, they want you to look at row 4. If you look at row 4, you're going to notice that every time you get a 4 answer, it is a double of a 2 fact. So if you look at your 2's, 2 doubled is 4, 4 doubled is 8, 6 doubled is 12. Why? Because 4 is 2 doubled. So when you're multiplying by 4, you're always going to get a double of your 2 fact. It works every time. Alright, so that's just a very quick run through of that packet and some things, especially multiplication, that you might want to look over before you come this afternoon.